Hi guys. So today we're gonna start off by talking about composition of functions. So composition of functions basically is, let me read what it says and then I'll explain it. So we're given two functions and here they're calling them f and g. And the composition of f with g is defined by this. This is the notation. Parentheses, f, and then it looks like a little o. That means composition, g. So that really is f composed with g of x. Okay, and a better way to write it so that you can actually use it to do math on is to, like, so when I say f of g of x, basically that's what I'm saying. Just replace that circle with your g of x inside parentheses, okay? And the domain of the composition is all x in the domain of g, for which g is in the domain of f. I know it doesn't sound very easy to understand, so we'll go through some examples, and I think by the time we're done, you'll understand. First thing I'd like to do, though, is I really want to explain this picture, because I do feel like if you like this picture is helpful in the understanding of what composition means. So, for example, if I start with this function or composition of functions, well, what do I always do? I always start, order of operations says I always start on the most inside parentheses. So I'm starting with x, which is right here. I'm going to input x into this system, or in the last video, I called it a machine. Okay. What does this machine do? It does anything you tell it to do, right? Again, we'll go through some examples. So let's just say here, I'm going to call this g of x, x squared, okay? And I'm going to input 3. So I put 3 into this machine. It goes through, does its thing, and plugs 3 in for x. I square it, out comes 9. Okay? Now, this is the difference. Composition of functions that then says, I put that 9 into another machine. Okay? So now I'm putting in, instead of just x, I'm inputting g of x, which in the example that we're using is 9. And then it goes through this f of x function. And let's say f of x is equal to x plus 4. Okay, so I put 9 in, it goes through this f machine, and what's going to come out? Out comes 9 plus 4, which is equal to 13. So that would be my composition. This would be f of g of x. Notice it's always going to go through the inside function, which is my first function, right? It's my first function first. And then after that, it goes through the outer function, which is my f of x function. Okay, sometimes visuals help. So there you have it. Using the graphs below, evaluate f composed with g of 1. So again, we start at the most inner value, which is 1, and it's asking me for g of 1. So I come over here to my g of x graph. Remember, g of x means g of 1, and Therefore, x equals 1. So I come over here to 1. I go up until I find where that hits this g of x function, and it hits at 3. So now, let's start here. We have f of g of 1. And we just found out that g of 1 is equal to 3. So now I want to know what is f of 3. Well, now I have to go to my f graph. And my f graph, f of 3 is when x equals 3. What is f of 3? So here it is. It's 6. So f of 3 equals 6. Therefore, f of g of 1 is equal to 6. So notice I'm first putting it through my inside function, my g function. I'm taking that output, and then I'm putting it into my f of x function, and out comes 6. So I hope that's clear. Now let's do the same thing with actual functions. And also notice here it says find the domain. And I'll describe domain for you in just a minute. So A, we start with f composed with g of x. And always, always change it into f of g of x. Okay, so now this is equal to f of, and what I'm going to put inside is g of x, right? G of x equals 3x plus 2. Okay? Perfect. Now, I want to know what f of 3x plus 2 is. And I know we've talked about this, but let me go through it again. Remember that if I have f of something equals, remember, those are going to be my x's. So let's say I have plus 5. Right? So if this is x, then this is x. If this is a heart, then this is a heart. What do we have now? We have f of 3x plus 2, which is going to equal 3x plus 2. That's going inside my parentheses, plus 5. And I can simplify this now to 3x plus 7. So that would be my f of g of x, if it was f of x equaled x plus 5. But that's not what f of x equals. So let's take this, move it. Let's see, where can I move it? Okay, I'll move it there. So we have f of 3x plus 2, and we've been told that f of x is equal to the square root of x minus 4. What goes in my parentheses? 3x plus 2. Same here, 3x plus 2. So this is equal to the square root of 3x plus 2 minus 4, which is equal to the square root of 3x minus 2. So this is my composition, okay? Let's do the domain for this. So the domain. Well, if you remember the picture that we have some input going into some like black box. We have an output. That output's going into another box. And we have our final output, which is a composition. Well, the first thing that we have to make sure is that whatever this input is can make it through the first box, right? The first black box. So I look up here at my g of x, and is there any value of x that is unacceptable to put in there? Like, is there anything that would make the denominator equal to 0? Is there anything that would make me take the square root of a negative number? Is there anything that shows me that there is some values of x that will not be allowed? I can put anything in for x there. I pick a number, any number, multiply it by 3, add 2, no problem. So my domain here for the first function is all real numbers from minus infinity to positive infinity, okay? So out comes everything. If I put in anything, out it's gonna come anything. So my range here, just so we can see it, my range is also from negative infinity to positive infinity. So every number possible can go into f, but f is the square root of x minus 4. So can any number go into the square root of x minus 4? This is my input. Now, what values are not going to be allowed into f? Well, it doesn't have anything to do with the actual original f of x, because that will never be there alone. All I'm doing always is putting in whatever comes out of g of x. So I don't have to worry about my f of x function alone. I have to worry about my inner function, which is my g function. That first has to be good, because if I put something bad into there, it's never going to make it into my f function. But once it comes out of g, it now is a composition. So now I want to look at my domain for the square root of 3x minus 2. Because that's the only thing that's coming out of this function, okay? So I look at this and I say, well, I have to remember that the only thing that x can be is a value that makes what's under the square root greater than or equal to 0. So to find my domain here, I say 3x minus 2 has to be greater than or equal to 0. 3x, I'm going to add 2 to both sides, is greater than or equal to 2. Divide both sides by 3, and I get x is greater than or equal to 2/3. Now, that means that if I put any value in for x that's not greater than or equal to 2/3, I'm going to have a problem. For example, let's see, let's get a new color. Oh, let's use blue. So let's say I don't listen to this domain, okay? Because, so now the domain of the entire function, let me write that. The domain of this entire composition would be, well, x has got to be greater than or equal to 2/3, which means I can only start at 2/3. And I can go all the way to infinity. And that's true also because I can put any value into f that's coming out of G. Okay, so I don't have to worry about G by itself, but I do have to worry about the composition. So let's just test something. What if I put in 0 into my composition? Well, so I have f of G of x is equal to, and we know it's equal to the square root of 3x minus 2. So if I put x equals 0, then first thing it's going to do is it's going to be g of 0, which equals 3 times 0 plus 2, which equals 2. Okay? All right. Out comes 2. And I want to know what f of 2 is. F of 2 is equal to the square root of 2 minus 4. Oh, I can't do that. That's the square root of negative 2. No good. So I just showed you that if I pick a number less than 2/3, or at least if I pick 0, it won't work. If I pick 1, it will be a different situation. For example, f of g of 1. Well, that's equal to f of, now I plug 1 in for 3x plus 2, which gives me 3 plus 2 is 5. I plug 5 now into my f value, and I get the square root of 5 minus 4, which equals the square root of 1. All right. So if I do B, I'm now looking for g of f of x, which is equal to g of f of x. And now, again, I have this inside function, which is f of x. So this is g of, and let's put f of x in here, x minus 4. Okay? And now I have g of the square root of x minus 4, and it's going to be it's going to be equal to, remember I said just take 3, whatever's in the parentheses, I'm going to use that, plus 2. Here, let's do it like this. Well, in the parentheses is going to be square root of x minus 4. So square root of x minus 4. This is my composition, 3 times the square root of x minus 4 plus 2. That's my final answer. Is that the same answer as we got before? I'm certain it's not. No, this is my answer from before. So now I found my composition. I have to think about my domain. So remember, first thing it's going to do is it's going to go through my f function, which is now this function. So first thing it's got to do is x minus 4 has to be greater than or equal to 0, or else it's not going to make it through my first function, so it can't go into my second function. add 4 to both sides. X has got to be greater than or equal to 4. So this is X is greater than or equal to 4, or in interval notation 4 comma infinity, going into my first function, f. Now notice, f is the square root of x minus 4, so if I put in 3, it's just going to blow up, right? 3 can't go through. 4 is the first number that can go through. It goes through. If it goes through, it goes into G. And G is not going to stop anything. You can put any value in for G, so there's not a problem in G. And then out will come G composed with F. G of f of x, which is the same as G composed with f of x. Okay, so my domain has only really got to do with f of x. And f of x is it's in its original form for that function. So my domain for the entire composition, sorry, getting these backwards, of f of x is equal to 4 comma infinity. So it can be 4 or anything greater, and that is how you do it. For this function, we only care about f of x. Once it passes through f of x, there's no holdup with g of x. So that's why the domain is only focused on f of x. Okay? And if we look at the composition right here, we can see that that domain is what works. All right, next question. Find a composition of functions. Let me do both. If you don't want to watch both, you don't have to. I think I can do it a little quicker this time. So we have f of g of x, which is equal to f of g of x is 2 over x. Now, if I need to find my domain, I have to really look at this 2 over x, because that's my inner function. So I can make myself a note here. So far, the domain x cannot equal 0. Because if x equals 0, then I'm putting in something that's not real. I can't put in 2 divided by 0. There is no such thing. So as long as I say x can't be equal to 0, I've passed through my first function. Then I plug this 2 over x in to the f of x function everywhere there's an x. So I would have 3 times 2 over x divided by 2 over x minus 1. Maybe I should do it in different colors. I hope you like the color thing. If you don't, I'm sorry. I do think it makes it a little easier to see exactly what we're doing. Okay. Okay, perfect. Except that is not, first of all, that's not a sufficient answer, because if we want a fraction, we don't want a fraction over a fraction minus a number. We want to make it into one fraction. So I can get a common denominator in the numerator and in the denominator. Let's look at each one separate, okay? So if I start with, this is basically 6 over x over 2 over x minus 1. Well, let's look in the denominator. What's our least common denominator? X. So I can turn, I'm leaving my numerator alone, and I say this is 2 over x, because x is my least common denominator, minus x over x, because x over x is the same as 1, right? So this is equal to 6 over x divided by 2 minus x over x. Now, there's a few things we could do. One is I could multiply the top. I could multiply by x over x. In that case, this x would cancel with this x, and this x would cancel with this x, and I would end up with 6 over 2 minus x. Or if you feel more comfortable with keep, change, flip, we can do 6 over x divided by 2 minus x over x, which is equal to 6 over x. This is the keep. Change division to multiplication. Flip. Keep, change, flip. So flip the second fraction, x over 2 minus x. Again, the x's cancel, and I end up with 6 over 2 minus x. Okay? So that is A. And our domain, well, we already took out here, x can't be 0. And now here, x cannot equal 2. So if I were to draw this on a number line, let's do a number line out here. Here's 0, 1, 2. And I know that x can't be equal to 0, so I'm going to put an open circle. I know x cannot be equal to 2. I'm going to put an open circle, and that's it. It can be everything else. Once I put it on this number line, it becomes much easier to write this in interval notation. I start off, let's see. So I start off, remember we always start from the furthest left. Furthest left here is negative infinity. I can go all the way up to 0. At 0, I have to stop. So, and I can't go all the way to 0. But I can then start again right past 0. And I'm going to go, so I'm going to say union. I'm starting right past 0, so 0, but not including 0, going all the way to 2. And again, I can't get all the way to 2 because 2 is not allowed. So I say go to 2, but don't go all the way. And then I pass 2. I start right past 2, and I can go all the way to positive infinity. So this would be the domain of A. And I think that's sufficient. I don't think it's necessary for us to go do B. If you have any questions or if you'd like me to do B, let me know. I'll be happy to. A city manager determines that the tax revenue are in millions of dollars collected on a population of P thousand people is given by the formula R of P is equal to 0.03 P plus the square root of P. And the city's population in thousands is predicted to follow the formula P of t is equal to 60 plus 2t plus 0.3 t squared. And it's basically telling us a couple of things. It's telling us R equals revenue. And it's actually tax revenue. It's telling us that P is equal to the population. And it's telling us that T is equal to the time in years. All right. Now, we want to find a formula. So here's the question. Find a formula for the tax revenue as a function of the year. Basically, we want to find, what they're asking for is R as a function of T. And as you can see, we don't have that. But we do have P as a function of T, and we have R as a function of P. So I could write this as R of P of T. Why is that the revenue as a function of years? Because look, here's my input. My input here is time. I'm going to call this time. And my output, so this is my input. This is my output. And my output is revenue. So if I can make this happen, I can put in time and I can find revenue. So let's see how that works. We have R of, well, we know what P of T is. So we can put P of T right inside that function, which is 60 plus 2t plus 0.3 t squared. Okay. Now let's find R, because now look, I have R as a function of t, don't I? This is R of t. So what we're going to do is plug this in to my revenue. So I get R of this is, so R of P of T is equal to 0.03. Now, wherever I had a P before, I have 60 plus 2t plus 0.3 t squared. By the way, notice the difference between my plus signs and my t's. I always put a little curl at the bottom of my t's so we can tell the difference, okay? So now I'm looking at this function. Wherever I see p, I have to plug in my formula for p. So 0.03p plus the square root of 60 plus 2t plus 0.3 t squared. And now I have, don't I have revenue as a function of time? And it is equal to 0.03. I'm not going to multiply this all out. It's not necessary. Okay, and that would be my final answer. Here, the domain actually is all real numbers because no matter what I put in here, no matter what I put in to this square root, I have 60. Well, t is going to be a positive number. I don't want to talk about what happened previously. I want to know what's going to happen as time comes. Okay, so t is going to be a positive number. I have a positive number plus a positive number plus a positive number, which is always going to be a positive number. I can take the square root of any positive number, so I don't have to worry. My domain is all real numbers. Okay, and hopefully that clears up composition. Now we want to talk about decomposition. I don't think you have any homework on this right now, but this is going to be a very important calculus topic. So I want to go over here while we're talking about composition. Let's talk about decomposition just so you can see an example. Basically, this is saying find two functions. So I'm going to find an f of x and a g of x, right? I want to find two functions, f of x and g of x, such that when I do the composition, I get this. Okay, and very important, it's saying neither function may be the identity function f of x equals x. Why is that? Well, if I say one of them is f of x equals x, I don't have to do any work. I just say f of x, I say g of x equals this function and f of x equals x, and I just plug it back in and it doesn't matter. So we have to do something a little more fancy than that. So let's talk about f of x and g of x. And we know that f of g of x is going to equal h of x. And h of x is equal to the square root of x minus 1 divided by 3. So first off, there's not just simply one answer. There's multiple answers. Okay? So don't worry if you don't get the same exact thing. But I'm going to look at this, and I know that I have this inside function g of x. So let's figure out what's inside of the function first. Well, I have a few options, but I'm going to say, let's g of x equal x minus 1. Okay? So now I'm going to take x minus 1, and I'm going to put it through my f function. When I do that, I need it to equal this. And remember, whatever's in here is going to go wherever x is in my f of x. So if I say f of x is equal to the square root of x over 3, notice what happens, and you should always check your work if you're not sure. So let's start here and see if when I do f of g of x, I end up with h of x, just like I'm supposed to. So I start off with f of g of x is x minus 1. So now I'm going to take x minus 1 and plug it in. Everywhere in f of x, there's an x. So I have the square root, x minus 1 divided by 3. That's what it was supposed to be. Check. So I found two functions that I can use, one for f of x, one for g of x, that when I put them together as a composition becomes h of x. And what I've done is decompose the composition. I started with the composition and I found two functions that would make it work. All right. So I have a couple more examples just because I like to make sure that you understand. Again, this has more than one possible answer. So we have f of g of x. And I'm going to now be looking at my h of x. And I want to see like what I can find to make g of x so that when I compose it with f of x, it's going to be h of x. So if I look at this, I can kind of see this inside function. I'm hoping you can see it too. If you can't, let me show it. This is like an inside function. And then there's an outer function there that's squaring that, isn't there? So what would happen if I make g of x equal to the cube root of x plus 1? So that now kind of compresses down to x for my f of x, which I'm going to say is equal to whatever g is, which is, we know now, I'm going to square that and subtract 3. And remember, this is really just x. Okay? So I would say that I can use x squared minus 3 for my f of x. Let's see if that works. Because it says then check. See here, right here, it says check by composing the functions to obtain h of x. So let's do it. I have f of g of x, which equals f of g of x is the cube root of x plus 1. Now I'm going to plug that in, so this right here, into my f function everywhere there's an x. So I have the cube root of x plus 1 squared minus 3. And let's look back at our original function, cube root of x plus 1 squared minus 3. Oh, perfect. We did it. So that's the difference between composition and decomposition. This one's a little tricky. I put this in here for a reason. If you want to play with it before I do it, feel free. Just pause the video, see if you can figure it out. But there's a little trick here that would help. So if I do a little bit of algebra, I can factor out a negative here. And then this would be x plus 1. Nice. Now I can kind of see my my functions, can't I? If I make x plus 1 my inside function, which is g of x, and I make f of x my outside function, remember I'm going to plug in x plus 1 everywhere there's an x in f of x. So I would have x squared minus x. This would be the solution. And I know that it's not that easy to see. There is another solution. I'm going to see if you find another solution and you think you're right, do what I'm about to do, check it. So we have f of g of x, which is equal to f of g of x, which is equal to, everywhere there's an x, remember, I'm going to put x plus 1. Okay, that's pretty much what I got after I did the algebra. Let's distribute this negative. Look at that. That's exactly what we started with. So it's always helpful to go back and check. Okay, Let me see how many more I have. Oh yeah, let's do this one and then we'll do the graph and then we'll be done. So it says write f of x as the composition of two functions. So now they're telling me my two functions are g of x and h of x. My inner function is h of x. That's what I'm going to look for first. So let's say h of x. I'm going to make h of x 5 minus x squared. That thing under the radical. And then I'm going to make g of x. Now remember, that's going to go in wherever there's an x. So 3 doesn't have an x. I don't have to worry about it. I need to make here the square root of x so that this h of x function will replace x and it will become 3 plus the square root of 5 minus x squared. Let's check it. G of h of x is equal to g of 5 minus x squared, which is equal to 3 plus the square root of 5. You know what? Let me do it in color. I don't know why. Colors, I think, always really help. So 5 minus x squared. Remember, that would be normally my x. And this would be normally x. But I'm going to replace it with 5 minus x squared, which is exactly what we started with. This equals f of x. So check. All right. And I wouldn't worry so much about this right now, but I promise it's going to be very useful in the near future. Okay, so let's see, do we want to do all of these here? All right. I don't think so. Can I don't think I can edit it. No. Okay, so let's do for sure A, for sure B. And we'll do them all. It won't take that long. Okay, so let's A. What A means, what this notation means is f of minus 2 plus g of minus 2. Okay? And now I go to my graph. If you notice, the blue graph is f of x. The pink graph is g of x. So I get that this is equal to, and I go to -2. Here's -2. Let me get a more vibrant color. How about, ooh, that's a very vibrant color. Okay, so here's -2. And f of -2 is right here because it's going to be on the blue graph. And that number is, I'm going to erase this. Oh, it tells me, never mind. So I'm looking at this point, and it tells me when I plug in -2 for f, I get 2. Plus g of -2, well, same place, just up on the pink graph, and I see -2, 3. This is 3. So I add those together, and I get 5. So A is 5. B, I have f composed with g of 7, which is equal to f of g of 7. And again, I'm going to put different colors on the inside. All right. So this is equal to f of, well, I have to find g of 7. Remember, the 7 is my x value. So I go along, here's 5, 6, 7. So right here is 7. And I am looking for g. G is pink. So I go up and I find right here, g of 7 is equal to 5. Now, I go here, and I want to know what is f of 5. So I look at 5, which is right here, and I want to know what f of 5 is. F is blue, so I go up to my blue graph, and there's my point. I read it, and it is 2. So f of 5 equals 2, and f composed with g of 7 equals 2. See, we have g minus f of 6, which is equal to g of 6 minus f of 6. So g of 6, let me erase all these little marks from before. Okay, so g of 6, we go out to 6, which is right here. G is pink. I go up. There's my point. 1, 2, 3, 4. So g of 6 is 4 minus same 6. I just have to go to f. F is blue, minus 1. So this is equal to 4 plus 1, which equals 5. Okay. D, we have g over f of 8, which is the same as g of 8 over f of 8. Now, let me erase these points. G of 8, there's 5, 6, 7, 8. Let's see, 10, 9. I think, let me see. This point right here is 8. And so g of 8, pink, 6, divided by f of 8, blue, right here. So I was here, and now I'm here. And I go 1, 2, 3, that's negative 3. 6 divided by negative 3, negative 2. There's my E. I'm sorry, there's my D. And last we have our E. E is, I have F times G of 4, which is equal to F of 4 times G of 4. Notice it's not composition, it's multiplication. So I have F of 4. Here's 4. My F is blue. There's F of 4. That's 5 times G of 4 right here, negative 3. And I get rid of this. Definitely don't need this. I don't need that either, but I definitely don't need this either. This equals negative 15, and that's my solution. So let's write them in. This equals 5. This equals 2. This equals 5. This equals negative 2 and negative 15. And that concludes composition of functions. Thank you for watching.